Hi, and welcome back to the Learn to Code by Writing Space Invaders course. This is lesson number 11. In the previous lesson, we finished off the code to let the player fire multiple bullets up the screen at the same time. And we were using arrays to store our multiple bullets, and then using a for loop to step through that array and modify and update and draw each of the bullets. But one of the loops we were using was actually inefficient in that it was performing more operations than it needed to. So we're going to discover what that is and how we can fix it in the next bit of coding. So if we have a look in our code to find out where this problem is. So I'm going to load in my, let me just click in here again, load in my lesson 10 code and come into the coding bit itself. So if I scroll down here, the code we're looking for is in the check player fire function. So we have that here. And if I go to smaller font size so we can see what's going on, we're using a for loop to step through each of the player bullets in the array. We're basically checking them to see, so if the user has requested a fire, so they've pressed the fire button, we're going to go through each of these bullets and check to see if that bullet can be fired. If the bullet can be fired, we're going to fire it, and then we're going to tell the system that we have fired a bullet, so we don't need to fire any more. But the test for whether we are still looking for a bullet to fire is done here, and that's done inside the loop. So our loop will actually keep on going until we've gone through every single bullet. So if we come in here, so think about the very first time somebody presses the fire button. They press the fire button and our test here says the fire button has been pressed. Our for loop starts looking at the first bullet in our bullet array. It says we're still looking for a bullet to fire, and it will find it on the very first try. That bullet will be fired, and we will say now that we don't need to find any more bullets. So our program, our software, will get to the end of the for loop here and go back round again to the start. And we will now be doing bullet number 2. We will check if we're still looking for a bullet to fire, and that will be no, we're not looking for one. So we will go to the end of the for loop again. We will then come back up for bullet number 3. We're not looking for a bullet. We will end the for loop. Bullet number 4, and then again up for bullet number 5. So we've found what we need on the first pass through our for loop. But the next 4 iterations, or an iteration is just another go through the loop. So the next 4 iterations of our loop, we're just simply marking time till we get to the end of our bullet list, and just trying to get out of our for loop. And that's very inefficient because we've locked our program up, looping around here, basically doing nothing. And at the moment, we're only checking for 5 bullets, so that's fairly minimal what we're doing there. But say we were going through a massive list of objects, and say we were going through our Space Invader array, where we're maybe going to have 20 or 30 objects, and we might be doing some collision detection with bullets, so we might be doing quite a lot of calculations based in there. So what we need to think about is how can we refine this loop so that we can cut out that wasted time. And again, in gaming, any wasted time can very greatly slow down the rate of our playing. So think about whenever you're playing one of your PC games or Xbox games. There's a lot of things going on, and sometimes you do find that the frame rate starts to drop when lots and lots of things are going on. So there's a lot of effort put into streamlining our code to make sure that we don't waste time needlessly. So let's start having a think about how we can fix this. And to do that, we're going to go and do a couple of little test programs to show you different ways in which we can do looping. So let's come out to our console again. And I've just loaded in lesson 10, so I know nothing's changed there. If you're just following on from the previous lesson, make sure you save your work so that your lesson 10 code is all saved correctly. Because what we're going to do is we're going to create a new cart which will overwrite everything currently in our cart. And we now have a new program. So if I go into our code, and again I'll do Control A and delete everything, and then put in our script Lua tag and our function tick. So we're going to do a similar idea to our previous test program where we were printing out the squares of a series of numbers. So I'm going to create my squares array, and we're going to then make it to be the squares of the first 10 numbers. So 1 squared is 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So we have our squares array sitting there. We're then inside our tick function. We're going to clear our screen. Just tab that in by 1. And then we're going to print, and we're just going to print out, first of all, how long our array is. So print hash squares, and we're going to print that in the top left corner. And then we're going to do our for loop. So for count equals 1 to number of elements we have, do, and we're going to print the element of our squares array pointed to by count, and we're going to print that at 0, and then brackets count times 8 to start stepping it down the screen. And then we're doing our end. So let me just tidy a bit so we can see everything in one go. Okay, so we have our complete block of code here. Let me just give us a bit of extra space in there. Okay, so if we run this then, we have a problem. So line 12 near end. So line 12, 10, 11, 12. So print, and I've missed off a bracket at the end of that line. Okay, so let's run that then. So that's telling us we have 10 elements in our array, and those elements are 1, 4, 9, 16, and so on. So back into our code here. Okay, what we want to have a look at now is how we can get out of our loop if we have a certain condition met. So say we decided that we were running through our array, and if we get to a value which is greater than 30, at that point we want to break out of it and not print anything else. So at the moment our for loop is quite rigid in that it says we're going to create a loop, and it is going to count from 1, and it's going to keep going until it gets to this number here, which for us is going to be 10 because there are 10 elements in our array. So really the for loop is saying that that's the way I work, so you're stuck with it really. But this idea of getting out of a loop before it actually finishes is of course something which comes up a lot of times when we're programming. So there are some ways in which we can get round it with a for loop, and we're going to have a look at those at the end because they're not always the best way to do it. What we're also going to look at here is there are different types of loops we can use depending on what our conditions are for continuing in the loop and for exiting from the loop. So let's start having a look at these. So each loop that we're going to look at will need to execute this line of code where it prints out the square of a particular number. Alright, so again, this value count is the one that's working its way through each element in our squares array and then printing it out on the screen and one above the other. So that's what our loop will have to contain. So we're going to have to look at different ways in which we can go through this loop. So let me take out these two lines here. So that's our for loop now taken out of the equation. The first loop we're going to look at is something called a repeat until loop. So we're going to say repeat, and then it repeats until we get to some expression. Very much the same as we do in an if statement. Okay? But one of the things we have to look out for with this type of loop is that our count variable, there's now no reference for that at all. So one of the big advantages that a for loop has is that it automatically does this counting for you. So you saw there we did a for count equals 1 to the number of elements in our squares array, and it would automatically go round the loop, and each time it would increment our value count. Increment means just simply adding one onto it. But with this repeat until loop, we don't have that automatically built in, so we have to actually do that ourselves. So what we need to do is we need to first of all create our variable count and initialize it to the first value in our array. At the end of our loop, we then need to update our count. So count equals to count plus 1. And we've now got our loop working. So we are saying here, coming in, we're saying our first value that our array is going to work with, so our loop is going to work with is 1. We're then going to repeat, printing out that particular element of our squares array. We're then going to move on to the next element, and then depending on whether this expression is true or false, we're going to carry on going round our loop. And the logic here is that because we're doing repeat until, we will carry on going round and round this loop until whatever we say in here is true. Very similar to our if expression. So we said that it would be quite good if we could come out of our loop if the square value, so the value stored at this particular element in our squares array was greater than 30. So we could say here until squares count, so that's the current element we're looking at, is greater than 30. And that should now allow us to exit out of our loop. So let's have a look and see if that works then. And you can see here, it's now saying there are 10, so the first number at the top there is there are 10 elements in our array, which is what we put in. And it's then starting to print them out, so 1, 4, 9, 26, 25. It was then saying that the very next one that was going to print out was 36. And of course that's bigger than 30. So that's when our loop exited. So let's go back into our code again. So this type of loop then, you can see it has this exiting function built into it. But this exiting function only works on the conditions which we've specified. There's no automatic exit function from the loop. And if you think back to our for loop, whenever we were setting that up, it would use this count variable, and it would say from count, so for count equals 1 to a certain value, which in our case was 10, because that was the number of elements in our squares array. So our loop would go round and round, printing out each of the elements of the array, but when it got to the 10th element, it would then stop, the loop would end, and it would carry on with the rest of the program. Our repeat loop, however, our repeat until loop, at the moment, it's only ever going to exit when our value in the squares array is greater than 30. So if you think about how it's coming through here, we start off looking at the first element in our array, and we print that value out. We then update our counter, so we're now looking at the second element in our array, and we're testing that. So our first iteration through, we've printed out 1, but we're now testing the second element, which is 4, and that is not greater than 30, so our loop will continue. We'll then print out the 4 and then test the 9. Our loop's still not finished, and it will carry on until we print out the 5th element in our array from here. We then increment our count value to 6, and we then access the 6th element in our squares array, which is the 36 number. So at that point, 36 is greater than 30, so our loop ends. But what if we had put in a condition of 300 here? Again, it works in exactly the same way. We'll print out the first element, test the second, print out the second, test the third, and so on, until we get up to our 10th element, where we will print out our 10th element at this point here. We will then update our count value to the 11th element, and then we will try and test that. But there is no 11th element. The 10th element is our last one, so the 11th element just doesn't exist. And this will actually then give us an error in our code. So we can actually try and run that and see what happens. So again, we've run it there, and we now have an error coming up, and it's saying here that our script at line 18, we're attempting to compare a number with nil. So there's our line 18, and what's happened is it's tried to get element number 11 from our squares array. That element doesn't exist, and if a number doesn't exist, it comes back as a nil value, or a null value if you're from other programming languages. But nil values is basically, it's absolutely nothing. It's not 0, it's nothing. So you can't compare nothing with 300, and that is then the error message we're getting up here, the attempt to compare a number with nil. So our loop at the moment, it has the possibility, if we're not careful with our exiting conditions, we can introduce bugs into our code, and sometimes these bugs can be quite hard to find. So if we are using this, we obviously do need to then have our natural end to our loop, and we do need to specify that in our exit condition. So in this block of code here. So let's see how we can actually do that then. And let me just go to a smaller font size so we can type in a slightly longer line here. So we've got one of our exit conditions here is where we're checking to see if we have a square, our square has got greater than 300. And we know at the moment that's not going to happen. What we are going to test for, if I just put it down here, the condition we are testing for is if our counter value has got greater than 10. So in other words, if we're now going to try and access the 11th array element, that is going to give us an error. So we've actually got to the end of our loop when our count at this point here is greater than 10. But we have to think about how are we going to combine this condition with this condition. And it's actually quite simple. We can use the words and or in our conditions. But we have to be very careful about which way around we do it. So I could say here, this is a condition. So I'm going to put that out of there. And I'm going to put it in behind this one. Okay? So we have one condition here. And again, this is where, remember we said about the brackets being optional in these. By putting them inside brackets, we can see that that is one expression. And this is a second expression. So the brackets do help you see where the expressions are. And we now need to join these two together with one of our words. So if you think about it, we want to continue in our loop until our square value becomes greater than 300, or our count value becomes greater than 10. So this is an OR condition. So we just type in the keyword OR. But let's have a look and see if that actually works or not. So let's run that. And we get our same error that we had before, where we're attempting to compare a number with nil. Well, if we look at our code, it should become apparent as to why that happens. Our code will always be executed from going down, but also within a line, it's executed from the left to the right. So if we think of what our code's going to do, it's going to have printed out element number 10. It's moved the count on to element number 11. And we then do our until tests. And the first test we get to is our squares with element count greater than 300. And if you think about it, count at this point in our code is going to be 11. So that is going to give us this nil error. So by putting this condition first, it means that we never actually get to test that before the code fails. So what we need to do is we need to make sure that the condition which stops the error happening is the one we test for first. So we're going to cut that out and we're going to paste it in there, and we're going to say OR, and then we're going to take out this OR. So if we now think about that final state again, so again we've just printed out squares 10. Our count value has been incremented to 11, and now we start executing our until statement. So the first condition we come to, or the first expression, is count greater than 10. Because count is 11, this means that our until has now found one of its exit conditions, and it will exit. The OR bit here, it won't actually execute that line of code because we've already decided to exit here. And that means that we won't then try and find the 11th element of our array and everything should work. So let's try running that. And there we have our code now working correctly. Okay, so let's just recap on that. We now have a repeat until loop. And pretty much every programming language you come across has these structures. They might not call it that. So if you were programming in PHP, for instance, we would have a do, and down here we'd have a while, so that'd be a do while loop. But it does exactly the same thing. We specify where the start of the loop is, and we then have at the end of the loop, we have a series of tests, and we loop round until we get those tests giving us an exit condition. Yeah? So this is our repeat until. The repeat until then, as I said, we have to then create our own incrementing system, so our own counter, and that's what we've done around here. So we had to create a variable outside of the loop, and then inside our loop we're working with that, and we then have to then make sure that we detect all the correct exit conditions, but also test those exit conditions in the correct order that stops us getting any errors where we try to access things that don't exist or do anything else silly. Okay, so we have our repeat until loop. But one of the characteristics of our repeat until loop is that no matter what we do, this loop will always execute at least once. Say we came in here and we said we want to start off at count number 12. Our software will come in and it has to get through all of this code before we ever test to see whether we need to go round the loop or not. So at count number 12, we will come in here and it will try to print out this block of code here, and our squares element 12 will of course not exist. So a repeat until has got the looping test at the end of the loop, which means that we will always execute one version of the loop no matter what we do. We can't get around that. Again, unless we put in extra code around here to test for various conditions, but that sort of defeats the object of it. Okay, so repeat until always executes once. Exit conditions are at the end of the loop. So now that we've had a look at the repeat until loop, we'll move on to the next one, which is the while do loop. But we're going to do that in the next lesson. So let's take a break from here. Make sure you save your code as lesson number 11, and then we'll pick up again in lesson 12. So see you later. Bye. Don't forget to visit the course pages for this project. There you'll be able to download the code for this lesson and get lots of extra hints and tips. You'll also get access to all my other programming, electronics and gaming projects. All the links are in the description below. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.